Okay, hello. This is the question 2, 2016, paper 1, split into 4 parts. So part A we'll get through. If you want to pause it now and just have a go at it first, fair enough. So I'll assume you're unpaused. Let's read the question. Z1 is given the complex number, the real part 1 plus 3i, the imaginary part, and the second complex number, Z2, is given as the real part 2, the imaginary part minus I. Now, always remember, in complex numbers, it's very important that the concept that I squared equals minus 1, and the secondary concept that I, which you probably will never have to use, is equal to the square root of negative 1. So let's get stuck in. So you're given the two complex numbers. You then asked to find a third complex number, which is made up of the first complex number plus twice the second complex number. So it should be very easy to get the attempt mark here. Now the attempt is 2 marks, that's the low partial, by filling in just the information you're given, Z1 plus twice brackets Z2. I have the answer on the next page, but just the final sentence here, find Z3 in the form A plus BI, where A, B are elements of Z. All that means is you want your complex number to have two whole numbers for A and B. I'm assuming this is going to turn out to be a fraction, and you're going to have to express it a different way. And the A, B are elements of Z just means that they're integers. It means they're positive or negative whole numbers. So you won't be dealing with decimals or whatever. So let's go straight to the answer. Now, before we get to there, I just have a few links built in. This will be on the PDF version of the notes, and each one of these links will bring you to information about complex numbers. It's worth being familiar with all the different parts here, adding, subtracting, multiplying, and dividing. In fact, this entire question we have coming up involves all those different scenarios. So I'll click on to the answer. So I've restated the question. Okay, I've then inputted Z1, and I've inputted in brackets Z2. So if I move left to right, remove brackets. Now for the first set of brackets, it's as if you're multiplying by 1, so 1 by 1 is 1. 1 by 3i is 3i, so nothing changes. The next brackets, you're multiplying 2 into it. So 2 by 2 is 4. 2 by minus I plus by minus is minus. 2 by I is 2i. You're now at your last step. Just simplify by adding what you can. So real parts add together. 1 and 4 is 5. And then 3i, take away 2i, 3 apples, take away 2 apples, so left with 1 apple. Job done. So that's part A, so it's worth 5 marks overall. Okay. Moving on now to part B. You're being asked to plot, just like in an XY diagram, you're being asked to plot Z1, Z2, and Z3. So take a second to pause this, use your answers from part A, remembering even if your answer Z3 was wrong from part A, it'll be accepted as correct in part B. Okay, assuming you're back. So I'm going to go straight to the answer. This is pretty simple. I plotted Z1, which was the complex number 1 plus 3i. Z2 was the complex number 2 minus I. And lastly, the one you calculated was 5 plus 1i. Okay, so that's pretty handy. It's just an argon diagram. It'll be a pretty standard thing to ask. Now, part C, okay, is hit or miss, either 0 marks or 5 marks, so no in between. It's a bit harsh, considering there's an awful lot of work involved here. So let's read it. Investigate if. Now you have the distance bars here, which in complex numbers means you're looking for the modulus. Let's find the distance of Z2 take away Z3, which you're going to have to calculate, so that's their asking subtraction, equals the modulus of Z1 plus Z2, so they're testing your ability to add complex numbers. So this is a fairly long-winded question. Let me go straight to the answer, you'll see why I say that. Okay, so I've broken it down into the first bit here, where I'm just calculating what the complex number Z2 minus Z3 is. So I put Z2 in, put Z3 in brackets, and I'm taking them away. So what's going to happen here, you need to be very careful, this minus is going to multiply into the second bracket. So first bracket's removed with a penalty, 2 minus I. Minus by plus 5 is minus 5, minus by plus I is minus I. The big mistake there is people don't put brackets in, and they think the question reads 2 minus I minus 5 plus I, which is wrong. It's minus 5 minus I. So you got to this stage here, I'm putting the star on, and you are adding the real parts. So 2 minus 5 is minus 3, minus I is minus 2i. So now you know that you're going to get the modulus of that particular number. We move on to the adding of Z1 and Z2. Now this is easier in the sense that it's an addition, so the plus sign multiplying into the bracket doesn't change anything. So we remove the brackets with a penalty, so it's 1 plus 3i plus 2 minus I. Add your real parts, 1 plus 2 is 3. Add your imaginary parts, 3i minus I is plus 2i. If you see there's a similarity between the complex numbers, they both involve the numbers 3 and 2. So when you find the modulus, the negative numbers are going to be turned positive by the squaring, and they are going to be the same, but let's prove it. I'll find the modulus of minus 3 minus 2i. Now the a part is minus 3. The b part is the number in front of the I. Okay, so that's the form a plus bi. Okay, so once you've identified a and b, they can go into the formula. Remember, the formula is basically a rearranged Pythagoras, and something we've dealt with before. So a goes in minus 3, b goes in minus 2. Go left to right, use by the rules of Bomdas, you should square first. So minus 3 squared is minus 3 by minus 3, which is plus 9. Minus 2 squared is minus 2 by minus 2, which is plus 4. Your final step is add the numbers simplified by 9 plus 4 is 13. If you square root your answer, you're going to make it more complicated, so you're better off leaving it in square root form. That's often called surd form. We do the second part then, find the distance of the complex number from the origin of the second complex number z1 plus z2, which we identified as 3 plus 2i. Again, the a is 3, the b is the plus 2, so put them into the formula. 3 squared is 3 by 3 is 9, 2 squared is 2 by 2 is 4, so 9 and 4 is 13, so both complex numbers are the same distance away from the origin. Now, you always need to state that, even though I'm stating it mathematically here, you need to state it in words so that you're verified true, yes, whatever. Anything in a positive form will get the marks. Otherwise, you may, depending on the year, lose all marks in a hit and miss question. But again, that's unusual in the sense that it's very, very harsh. And normally you'd have a split between low partial, high partial. So that's part C. Now part D, okay, is they're testing division. So they're saying find the complex number that's given by Z1 divided by Z2. Now, the rule for division of complex numbers is simple. You divide top and bottom by the conjugate of the bottom. So first thing we need to deal with is what's this conjugate? Well, simply right down here on the side, if you have a complex number 2 plus 3i, okay, its conjugate is 2 minus 3i. So all you're doing is changing the sign on the imaginary number. So if I plotted that really quickly, 2 plus 3i is somewhere around here. Its conjugate is always directly below its image in the real axis. Okay, and by definition then they will be the same distance away from the origin if you had to find the modulus. But in this case, we're just being asked to do the division. Again, your answer, if it comes out, they want it in the form a plus bi. In this case, a and b can be real numbers, so basically can be any number. Positive, negative, whole number, decimal, fraction, whatever. Okay, so I'm going to flick on to the answer. I've written it out here on the left side, okay, the question. I've inputted the two complex numbers, 1 plus 3i, which is z1 from part 1, 2 minus i, which is z2. Again, you were given that in part 1. So I'm multiplying top and bottom by the conjugate of the bottom. So the conjugate of the bottom was 2 plus i. So you can see that there. Then the reality with division of complex numbers, there is no real division. It's just more like a lot of multiplication. So I'm doing it out by one of the methods for multiplication. I'm writing the second bracket out twice, multiplying the first term into the first bracket, the second term into the second bracket. Now this is a method, multiplying a two-term bracket by a two-term bracket, that you must know. You'll be asked it repeatedly in the exam. And very easy for people to make a mistake if they're not being careful, or if they get distracted halfway through the question to make an error in their multiplication. So just go slow. So again, I multiply the bottom by its conjugate. So I've written it out, the second bracket out twice. First term in the first bracket, the second term into second bracket. So we go left to right and do the multiplication. 1 by 2 is 2. 1 by I is I. So multiplying 1 by anything doesn't change it. 3i by 2 is 6i. 3i by I is 3i squared. And this is where you bring in the concept that I squared equals minus 1, and we'll do that in a second. But I want to keep going and do the bottom part of the denominator of this sum. 2 by 2 is 4. 2 by I is 2i. So minus I by 2 is minus 2i. Minus I by plus I is minus I squared. Now what always happens in division of complex numbers, the i's on the bottom will disappear. So you see the 2i minus 2i is going to cancel out. So I'm going to simplify it. The top line first. I plus 6i is 7i. At the same time here, and just to be clear, you may not need to do this yourself if you know what you're doing, but I'm being very clear. I'm putting the -1 in instead of I squared, which is going to add an extra step. So I'll leave that to the next step. The bottom part, I've cancelled the 2i, take away 2i. I'm left with 4 minus the -1, which I've swapped in for the I squared. I need to go again and simplify. If you add the numbers, now I'm taking liberty here that you can see that 2 plus 3 times -1 is the same thing as 2 minus 3, which is the same thing as -1. So your top part of the answer becomes -1 plus 7i. That's done. You can't make that any simpler. The 5, I'm adding the 4 minus -1, which is the same thing as 4 plus 1, which is the same thing as 5. So you end up here with the complex number -1 plus 7i all divided by 5. Now that's not in its full state. What I need to do here is rearrange it to the two separate fractions. So it's the same thing as -1 divided by 5 plus 7i divided by 5. And that's, they've stated in the question, they want it in the form of a plus bi, not a plus bi all divided by something else. Okay, so that's part D. Okay, I put the marking scheme there in for the question, just showing you the different parts they have for it. So you can see the answers, but you can also see that they're giving, say for example, if you do any correct substitution for part D, you get 2 of the 10 marks. Yeah, that it should be doable just by even guessing the question. So always attempt the question. I'll say that every time we do a video. I can't state how important that is. If you're picking up 2 marks, 4 marks here and there in questions that you don't know how to do, you have a fairly good chance of passing with the questions that you can do. Okay, that's it for question 2, 2016, paper 1. Thanks very much for listening.